we have a radical equation here that we're told to solve. And normally with solving equations, we factor them first, right? The problem here is that I don't know how to factor fraction exponents. That looks weird. So I want to point out something to you. This is actually not a hard problem if you see something special about it. And I want to point out a similar equation, which I'll bet you could solve no problem. If this were x squared plus 2x minus 3 equals 0, hopefully you could work your way through that through factoring, right? It's not a whole lot different than what we have. It's a quadratic because it has a quadratic term, x squared. It has a linear term, this thing right here, which just has an exponent of 1. And then it has no exponent at the end. That pattern of 2, 1, 0 is what we actually see right here. Because 1/2 is twice the size of 1/4. And then there's no exponent at the end. So we have a quadratic pattern, meaning we can use a special technique called U-substitution to just make our equation that we're working on look like a quadratic equation, solve it, and then undo the change. So let's make that substitution. We're going to say u equals phi to the 1/4. And you might be thinking, how do I know u equals phi to the 1/4 and not u equals phi to the 1/2? Right? Well, one way you could try it is just try both. One of them is going to work, the other isn't. The other thing you can do is keep in mind that u is generally the linear term, the one in the middle with the smaller power. And then u squared is the bigger power, and 1/2 is bigger than 1/4. So check this out next. If u is equal to phi to the 1/4, what's u squared equal to? Well, that's phi to the 1/4 squared, which is phi to the 1/4 times phi to the 1/4, which is, if you remember how exponents work, when you multiply exponentials and the base is the same, you add the exponents. 1/4 plus 1/4 is 1/2. So great. We have now a way to rewrite this equation using u. We're going to say u squared plus 2u minus 3 equals 0. Now we can factor that pretty easily, right? There's nothing in front of the u squared that makes this challenging. And I'm just going to use the guess and check method. I guess that the factors of -3 are +3 and -1, because those will add up to +2, the linear coefficients. And I double check it by multiplying it out to see if I get the original thing. I do, so we can just move on. I always want you to double check your factoring, because if your factoring goes wrong, it's better to find that out now than later. And now what we're going to do is solve each of these factors separately using the zero product theorem. The zero product theorem says if you have two things multiplied together and the result is 0, either one of them is 0 or both of them are 0. But there's a 0 somewhere. We just don't know which one it is. So we have to consider them both being 0. U plus 3 equals 0. That means u equals -3. And the other one over here says u minus 1 equals 0. So u equals 1. Now, do not put -3 and 1 in as your answers. The problem is asking for phi, right? It wants phi. It doesn't want u. So we need to undo that change of u equals phi to the 1/4. I'm going to say phi to the 1/4 equals 1. And over here in purple, we have phi to the 1/4 equals -3. Now, if you're good with exponents, you can see there's a problem here. But I'm just going to walk through this in slow steps. What is phi to the 1/4? Well, that is the 4th root of phi. And what is the 4th root of phi? Well, that is the square root of the square root of phi, right? Now, here's the problem. The square root of something cannot be negative. Remember what we talked about at the beginning? Oh, I don't know if I did or not, but we're looking for real solutions. And real solutions, if you square root them, cannot give you -3. So this whole thing over here is a big old DNE. That gives us a DNE. We just ignore it. So we're done on the purple side. We're moving back to the green side. Phi to the 1/4 equals 1. That seems fine, right? You can have a positive 4th root. So I'm going to now raise each side to the 4th power. This is phi to the 1/4, and I'm raising it to the 4th power. Equals 1 to the 4th. See, I raise both sides to the 4th. The exponents cancel out here, and I just have phi equals 1 to the 4th, which is 1. So great, that's my answer. And we are all done with this thing. So your answer is 1. You ignore that negative 3, pretend it never happened. Now let's review the major steps. The key part of this problem is U-substitution and recognizing that quadratic pattern that I talked about. Okay, the exponents have to be in a 2-to-1 ratio to use U-substitution easily. And then, once you have the U-substitution made, you factored everything out, watch out for DNEs that show up because of weird square root imaginary stuff. Okay, you always have to make that substitution in reverse at the end. Once you find the solutions for U, you have to undo it and find the solutions for phi or whatever the original variable was.